Though it's still cold, my computer still has battery. So we're going to do some examples for the law of sines and the law of cosines. Now, we're going to build our intuition for when to use law of sines and when to use law of cosines. But in general, you can use law of sines if, go ahead and get some colors here, if you have two angles and a side, or two sides in an angle. Kind of, okay? So if we're talking about kind of how we've done triangle congruence, you might think of it as angle, angle, side, or angle, side, angle, or law of sines works for side, side, angle as well. Okay, now law of cosines works for two sides and an included angle or having all three sides. So this would be side, angle, side, or side, side, side. Okay. Again, some of it's just going to be building our intuition here. So, and you can always, if you forget somehow, you can always check, right? You can always try, and if you don't have all the letters you need, well then, you just use the other one. If you can't use your law of sines, then you just use law of cosines, okay? Or vice versa. So let's look at number one here. Here I have x, 10 centimeters, 9 centimeters, and a 43-degree angle. Again, so like we talked about at the beginning, I have two sides and an included angle, so that's law of cosines. And we'll see that it does work. So I'm looking for x. And this is kind of where the rubber meets the road here, because we found the formulas, but now we have to figure out how to use them, right? X squared, if you remember the law of cosines, x squared equals the other two sides squared, so 10 squared plus 9 squared, minus 2 times the other two sides multiplied, 10 times 9, times the cosine of whatever angle is across from this side, the cosine of 43. Okay, now the beautiful thing is that you can just use a calculator for this. So I've got my handy dandy calculator right here. 10 squared plus 9 squared minus 2 times 10 times 9 times the cosine of 43, and then we take the square root of my answer, and I get 7.02. So x equals 7.025, so 0.3, so 7.03 centimeters. Okay, now a lot of you might be asking, how much work do I have to show for something like this? Well, I don't know who's watching my video, but look, as long as you can set up this equation, that's the most important part, right? You need to make sure that you can set up this entire equation, and then the calculation, well, that's trivial, right? Okay, it looks like we got another law of cosines here. How do I know for number 2? Well, again, I have all three sides, right? So we're looking for this angle right here, right? So that's the angle I'm going to take the cosine of. So that means that I'll have 7 squared equals this, and then that'll be on the other side. So let's look at that. 7 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of x. Okay, again, once you recognize the pattern, it's really not too bad to just bang all this out, right? But I understand that it might be a lot to take in all at once. So here, maybe it's helpful for us to actually show some work here, because we do have to find the cosine of x. So 7 squared, okay, minus 6 squared minus 8 squared. Okay, so over here I have a negative 51 equals negative 2 times 6 times 8, that's negative 96, right? 12 times 8 is 96. I feel pretty good about that. And then times the cosine of x. So that means that the cosine of x is equal to negative 51 divided by negative 96. So x equals the inverse cosine of negative 51 divided by negative 96. Okay, so that took, I mean, you know, over here it was nice because we just had x squared. That wasn't too bad. Here we kind of had to do a little bit more. But the inverse cosine of 51 over 96 is 57.91. So that's 57.9 degrees. 57.9 degrees. Right, 57.9 degrees. Usually I'm just rounding to the nearest tenth for my angles and to the nearest hundredth for my lengths. But again, usually that would be specified. This is just convention for me. Doesn't really matter that much if it's not specified, but that's that. Okay, let's look at these two, 3 and 4. Okay, here I have an angle, a side, and a side, right? So I have two sides and an angle. That's nice. The big thing that I'm looking for here is that I actually do have, I have these two that match up to each other, right? I have 85 and 21 that are across from each other. So, and I'm looking for x and 15, which are also across from each other. So remember, law of sines, the sine of 85 over 21 equals the sine of x over 15. So, right, the sine of x equals 15 times the sine of 85 over 21. So then that means that the x is equal to the sine inverse of, or the inverse sine of 15 times the sine of 85 divided by, don't want that yet, divided by 21. Okay, so then x equals 15 times the sine of 85 divided by 21. Take the sine, the inverse sine of all that. And for x, I get 45.36, so that's 45.4 degrees. Nice. Okay, maybe one more. Here I have two angles and a side. And if I have two angles, man, I'm always feeling good because I know that I can find this third angle right here. Right? So yeah, it's actually nice because since I have this right here, it would be nice for me to know this angle. So 22 plus 183, that's 105. Right, that's 105. So that means that this would be 75 degrees. Nice. So now I have all three angles. And again, if I'm looking for x, right, x is across from 22 and 75 is across from 5. So, well, we can find x pretty easily. The sine of 22 over x equals the sine of 75 over 5. Of course, we do have to do some multiplying here, right? If maybe I multiply both sides by x and maybe both sides by 5 as well. So then 5 times the sine of 22 equals x times the sine of 75. Divide both sides by the sine of 75. And I get x equals 5 times the sine of 22 divided by the sine of 75. And I like to just wait until the very end to do any of my calculations. So 5 times the sine of 22 divided by the sine of 75 equals 1.939. So x is 1.94 centimeters. Not too shabby. And that's kind of what we would expect because 5 is not very long, and 22, right? 22 is a small angle, and across from a small angle, we have a smaller side. This triangle isn't really drawn to scale, but that's okay, right? Okay, let's look at the next page. Just a few more examples here. Okay. So here I have two sides in the included angle, that's side angle side. And since, again, I'm kind of looking, I'm trying to find this x across from 28, right? And I don't have either of these two angles across from these other sides. I just don't have it, right? Sadly. If I did, then I could use law of sines, but I don't, so I need to use law of cosines. So here we go. The 28 squared equals 16 squared plus 11 squared minus 2 times 16 times 11 times the cosine of 20. Oh, sorry. 8. Not 28 squared. Silly. X squared. Like, what am I looking for here? Yes. X squared. That's the side length I'm looking for. I have the angle 28. Okay. So then, well, again, this is just nice. We can type all this straight up into the calculator. 16 squared minus 11, plus, cold's getting to my brain. Maybe my beanie's on too tight. Minus 2 times 16 times 11 times the cosine of 28. 66.2 x. Oh, so x squared equals 66.2. Which again, maybe I don't even want to go there, I think. I just want to say what x is equal to, right? So let me take the square root of all this in my calculator. So then x is 8.136, so that's 8.14 kilometers, right? That's not too bad. Okay. We're still going. So again, think about what you have. Okay, I'm looking for x. I do have the angle across from x. And look, I have the angle across from this 7 right here. So that's law of sines. The sine of 26 over x equals the sine of 74 over 7. So 7 sine 26 equals x sine 74. X equals 7 sine 26 divided by the sine of 74. That's one thing I can type into my calculator. 7 times the sine of 26 divided by the sine of 74. 3.192, so x is 3.19. Not bad. My best friend's birthday is on 3/19. It's time to be alive. Okay. So, 2 more. I'm given all of the sides of this triangle. So again, remember, just think, I have this x, okay. Do I have any other angles? No, I don't, right? There's nothing else I can do, so I need to use the law of cosines here. So here we go. We use this one across. I almost feel like this should be like a different color, right? So 9 squared. Oops. 9 squared equals 5 squared plus 7 squared minus 5 times 7 times the cosine of x. And I'll let you punch this into your calculators a little bit. 9 squared, 5 squared, minus 7 squared, divided by negative 35. So be careful with your negatives there. And then I take the inverse cosine of that answer. And I get 101. So x equals. So I did the inverse cosine of negative. That was negative 1/5 is x. So then the cosine, or sorry, x equals 101.5 degrees. Not bad. Okay, one more. I'm looking for x, right? This is what I'm looking for. Oops, why did I do that? This is what I'm looking for. I'm looking for x. So, well, I don't have the side across from 28, but I can find the angle across from 8, right? 28 plus 94 is 122. So then that means this is 58 degrees. Yep, 152. Boom. Okay, that feels good. So now look, I have the angle across from the side. The sine of 58 over 8 equals the sine of 94 over x. So x equals the sine of 94 times 8 divided by the sine of 58. Sine 94 times 8 divided by 58. Oops, not divided by 58. Divided by the sine of 58. There we go. And so x is 9.41. 9.41 centimeters. There you have it. So just look, I would say there's all these different, side, angle, whatever, angle, side, angle, I don't know, angle, side, whatever that you can do. But I would say just try to look for what you have. Do you have the angles across from x, right? Do you have the sides across from your angles? And then if you can use law of sines, use law of sines because it's easier. And if you can't, use law of cosines. Hope that was helpful. Stay frosty, and I'll see you next time.